Welcome to lesson 1.3, which is all about significant figures and scientific notation. This lesson is actually pretty much the math that you're going to need to know for chemistry this year. If you understand these concepts, you are well on the way to understanding all the math that you're going to need to know for this semester. So these are super, super important. The first thing we want to talk about is significant figures. Significant figures are important because scientists around the world try to share information, and significant figures tell scientists who are reading data from other scientists just how exact their instruments were. So it gives them an idea of how precise their information is. So from this point forward, anytime you have a number answer, you will want to make sure and write it with the correct number of significant figures. Okay? So here are the rules for figuring out significant figures. First, if you have a number with no decimal point, so there's no decimal point anywhere in the number, you start at the right and ignore zeros until you get to the first non-zero number. This case, the first non-zero digit happens to be a 2, and then you keep counting to the left. So for this number, we ignore all these zeros and then start counting 1, 2, 3. So this number has 3 significant figures. These zeros are just placeholders. When we get to this number, again, there's no decimal point, so I'm going to start over here at the right, and I skip these first 2 zeros. Here's my first non-zero digit. It's a 6. And then I count everything going to the left. This 0 does count. It is significant because it's in between these two non-zero numbers. So I start at the 6 and count 1, 2, 3, 4, 5. So there are 5 significant figures in that number. If your number does have a decimal point, you basically start at the opposite side. So you're going to start at the left. Remember, no decimal point, start at the right. Decimal point, start at the left. Skip all these zeros, any zero, until you get to the first non-zero digit, then start counting. Skip, skip, skip. 1, 2, 3, 4. So this number has 4 significant figures. Again, we have a number with a decimal point. So I start at the left, skip this one, and start counting with my first non-zero digit. 1, 2, 3, 4, 5, 6, 7. So this number has 7 significant figures. Sometimes when scientists want to write a number, and like it says here, indicate that a 0 digit is significant, what they'll do is they'll put a decimal point at the end. Remember, these numbers had no decimal points? This number does have a decimal point, so I will treat it just like this number. I start at the left. My very first number is non-zero, so I start counting. 1, 2, 3, 4, 5. This number has 5 significant figures. They also might put a line over any significant zeros. So they're saying these 2 zeros are significant, count them. So this number has 3 significant figures. Because of that line, we count them. Another rule is if you have an exact number of things. So this is a counting number. It's not a calculated number. Not from a measuring device, so not from a scale or a ruler or anything like that. It is counted items. Every number is significant in a counted item. So here we've counted atoms. There are 310 of them. That means 3 significant figures because it's a counted number, not a measured number. Same here with this cups. We count cups. That's the amount of them. So there are 5 significant figures here. Every number is significant because it's not a measured number, it's a counted number. We're going to talk about scientific notation more in a minute, but in scientific notation, you only use the significant digits. So these 3 zeros would not be written down because they're not significant. These 3 zeros would not be written down because they're not significant. Start with the first non-zero number when you're converting numbers to scientific notation. We will talk in more detail about that in a second here. So when you have to do calculations with significant figures, there are some rules in how to write the final answer. That helps us keep track of how precise, like we said, how precise our instruments were. So when you're doing calculations in this class, there's some important things to remember. If you are adding and subtracting, the answer is written with the same number of decimal places as the least precise measurement in the calculation. So we're adding these three numbers together. This one in the middle here is the least precise. It only has one number past the decimal. This one has 3. This one has 2. So our answer can only have one number past the decimal. First thing we do, add all these up. We get 15.999, or 990, sorry. And the next thing we need to do is round that to one number past the decimal. This 8.2 has one number past the decimal. Sorry about that, y'all. So our answer needs to have one number past the decimal. So to round this, we get 16.0, one number past the decimal. Adding and subtracting. Multiplying and dividing is a little bit different. The answer has the same number of significant figures as the smallest number in the problem. This number has 2 significant figures. This number has 1, 2, 3, 4, 5, 6. So our answer can only have 2 significant figures. Multiply these two numbers together and we get this, 79.433865. But we have to round that to 2 significant figures, so we get 79. So multiplication and division is a little bit different than addition and subtraction. Right? Look back over those if you need some help. What I want you to do now is pause the video, do these practice problems. I will get you the answer key so you can check them. But do these practice problems. Make sure you understand how to work with significant figures. Moving on, scientific notation. Basically, scientific notation, we take really, really big numbers, really, really little numbers, and make them workable. Right? So make them usable to our calculations quite a bit easier. Okay. So first things, converting large numbers into scientific notation. Basically, the process is you move the decimal point, which is here at the end, to the left until we get to a number between 1 and 10. So we get just to the right of the last number. So starting here where my decimal point is, I'm moving it 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've moved my decimal point 9 places to get it right there. Then when we write down the number, you write down 1.74. Remember, I moved my decimal place to right here. And remember how we just talked about none of these zeros we want in our answer. The whole point is to get rid of all these zeros and make a number that takes up less space. So I got 1.74 times 10, and then my exponent is the number of jumps I made to get there, 9. So I did 9 jumps to move my decimal. 9 goes into the exponent. So that's converting big numbers. Converting small numbers, same principle, just go the other direction. Start here at the decimal place. Now I'm moving to the right. 1, 2, 3, 4, 5. It takes me 5 jumps to get here after the first number. And then remember, none of these zeros we want to write down defeats the purpose, because the purpose is to make our number smaller. Take up less space, not really smaller. It's the same size. But I get 2.305. That's where I move my decimal place to. times 10 to the negative fifth. Because I moved it to the right, it's a negative 5. That tells me that this is a really small number. A positive number tells me it's a really big number. But this is a really small number, so I've got the negative 5. 5 comes from that's my number of jumps that I did. Right? On your calculator, it might say E for exponent, because that's what this is, an exponent, right? And in order to do these problems on your calculator, look for that button, 10 to the x power. You might have to hit second to find it. Oh, it's right there. So that will help you do exponents on your calculator. All right, so scientific notation, adding and subtracting. When we add or subtract, first thing you do is add or subtract just the regular numbers. So for this problem, I got 7.52, 5.12, add them together. Leave the exponent as it is. So I'm here at 12.64 times 10 to the negative 7. But this is not in correct scientific notation because there should only be one place to the left of the decimal. So I have to adjust it, move my decimal point one place to the left. So I get 1.264. And because I moved one space, I add 1. Negative 7 plus 1 is negative 6. So I have to just add and then change my scientific notation if the number needs it. If we have different powers, so this one is 10 to the 5th, this one is 10 to the 8th, then we have to make them have the same exponent before we get started. So you will take the number with the higher power and convert it. So to go from 10 to the 8th to 10 to the 5th, I have to jump to the right, boom, 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 3 times. 1, 2, 3. Which have to put a 0 placeholder in there, right? So here, 1, 2, 3, to make it 10 to the 5th. So I've got 3.28 times 10 to the 5th, 1,720 times 10 to the 5th. Now I can add these together. Add my number, exponent stays the same. There's a lot of adjusting I have to do here, right? Because I've got to move this now 3 places to the left to make this number correct. Move my decimal place 3 jumps, and then I add 3 to my exponent because I moved it 3 jumps. So I end up with 1.72328 times 10 to the 8th power. 5 plus 3 is 8. One word of note, if you're using a graphing calculator, make sure you put in parentheses if you're doing this calculation on your calculator, or you will get the wrong number. Now, when we multiply and divide with scientific notation, it's a little bit different. The first thing you do, if you're multiplying, you multiply these two coefficients, multiply these two numbers together, and then add the exponents. You should have learned in math, you multiply, you add exponents. So we got 2.8 times 9.36 times 10 to the 8 plus 5, because we're adding those together. Multiply those two numbers, I get 26.208 times 10 to the 13th, because 5 plus 8 is 13. Then, as always, we need to convert. We moved the decimal point one place to the right to go from 26 to 2.6. Add an exponent, 13 to 14. Dividing, same way, just opposite, right? You divide these two coefficients, then subtract the exponents. Up here we added, down here we subtract. This should be review from exponents. So 1.75 divided by 5.23 is 0.3346, and 2 minus 5 is negative 3. Again, we've got to convert this number This time we're moving the decimal point one place to the right, so we subtract a number. But it ends up being 3.346 times 10 to the negative 4. Negative 3 minus 1 is negative 4. Okay? So we divided and then subtracted the exponents. Okay. Again, take a look at these practice problems. There's a addition, multiplication, division. Work through them. Try your hardest. Let me know when you've got them, and I will give you the key so that you can check your answers. Let me know if you have any questions.